Hello, this is Roberto and this is the HVAC my channel. Today we're going to be talking about ductwork sizing part 2, alright? So let's get into it. So what we have in here, this is pretty much an example, but let's understand very well the system, okay? So that's the most important thing. At times when I get a project, I always take maybe half hour, maybe 45 minutes, just explore room by room, just to get knowledgeable and more familiar with the building, okay? So to begin with, this example is going to be a classroom, okay? So let's put in here classroom. This is a classroom, okay? This is a classroom. And then in this classroom, what we're doing is we have a rooftop unit. And this rooftop unit could be, I guess, let's put it maybe with a DOAS, okay? But the DOAS is 100% outside air, right? Dedicated outside air. So we were explaining this in other videos, right? Or we have the type of mixed air system, right? Mixed air. So in this case, we're gonna do a mixed air system, all right? Mixed air. There we go. So mixed air pretty much is a combination of outside air, okay, and supply air. So technically in here, we already have these two components, outside air and supply air. Now I'm gonna put this in pink so that way everyone could see. This is the main duct, all right? So this is the main duct coming from the rooftop, okay? So this is the main duct, all right, coming from the roof. I'm just gonna put from roof, okay? From roof. Of course, you're gonna have risers and everything, okay? But this is the complete main duct coming from the roof. But this is actually I would call it supply air, which is in other words like a combination of supply air and outside air, okay? So because we're doing mixed air, DOAS, remember, is 100% outside air, but this is a rooftop unit, mixed air. And you might be wondering, wait a minute, why rooftop unit, DOAS? Well, DOAS is technically roof. It's on the roof most of the times. It's top unit, right? So that's why overall I'm putting DOAS and mixed air overall as a rooftop unit, okay? And the other side is actually the main, okay, this is the main duct for, okay, sometimes, you know, they call it trunk, main duct for exhaust air, or maybe we can call it also return air in this case. Okay, there we go. So these are the medium ducts. Whenever you are trying to size a ductwork, you need to understand the following, okay? So sometimes, most of the times when it's coming out directly from the unit, this is considered medium pressure duct. Most of the time. See, I'm just gonna put in here medium pressure duct. All right. But why is this considered medium pressure duct? Okay. So the reason is usually this is coming directly from the system, right? It's coming here and it's going to be injected into this box. This is a terminal unit called VAV or CAV. In this case, we're gonna put a VAV box. So this is gonna be called VAV. I'm gonna put a denomination in here. VAV, if this is on the first floor, I'm gonna put first floor. If this is the first unit, VAV 1. So see, first floor and number 1, because on the first floor I could have 20 units, so I would call it VAB 120, for example, okay? If it's on the second floor, VAB number 1, but depends on the company. So the reason I'm putting a VAB is because the classroom, based on the occupancy, it could be occupied, it could not be occupied, so that's why we put VAB. It's not constant volume, otherwise we would put it as a constant volume, okay? So this VAB. Now again, so this is coming from the rooftop unit and then comes here, and then we have the VAV, and this is the terminal unit that is delivering the final air distribution to the space. So on that side, what we call is low pressure duct. There we go. So in other words, I'm gonna put in here like this, coming out from the VAV terminal unit, we will put low pressure duct, low pressure duct. So just to keep consistent with the colors, I'm gonna put this as, here we go, main duct. This is the main duct, and this is the distribution duct. I'm just gonna put distribution to the space, right? Distribution duct, distribution duct to the space. And again, this is also supply air and outside air together, already mixed, okay? And then also, I'm gonna put this in white because this is always very helpful. I'm gonna put this as a low pressure duct most of the time, see? So now you can see, after past the VAB, we have low pressure. Before the VAB, we have medium pressure duct, okay? Also upstream, medium pressure, downstream, low pressure. This is the most important part for ductwork sizing. So that's why I'm doing this little by little. Okay, why? Because also in here, see, in the table that I have, oh, I'm sorry, this is white. I'm gonna put this as, there you go, the color pink. So in here we have low pressure or medium pressure. We need to choose. Alrighty, so now that we understand that, let's understand also the return side, okay? But since we're focusing very quickly on the supply side, okay, we need to know already the CFMs. That's the first step. Okay, you do a heat load calculation, you already did the ventilation. You know what, I'm gonna put everything in here because so this is the HVAC easy math. So see, you did the heat load calculation. All right, you did the heat load already. See, the heat load calculation is done, and you did the ventilation, of course, ventilation calculation, ventilation calc. Okay, it's done. And this is going to give us, of course, the supply air, and this is going to give us the outside air. And because this is mixed air, we're going to have a percentage of how much outside air you have supplied air. Okay, so basically these steps are done, heat load and ventilation calculation. So based on that and based on the space and envelope, we have, for example, that the CFM for this space is, I just want to put this in yellow just to keep consistent. This is going to be 285. Okay, 285. There you go. So this is 285 CFM. But sometimes we don't have a space in the drawings. So what we do is 285, and then parentheses, we put typical of 5. See, typical of 4. That's how we put it in the drawings. Of course, every company has different ways, but typical of 4 means that you only have 1, 2, 3, 4 supply diffusers. So that's why it's 285 typical of 4. So that means that every diffuser has 285 CFM. And otherwise, you're going to have to put 285, 285, 285, 285. So it's not a good idea. Now that we have that, see, 285, what we're going to do is, what is the VAB size? Because based on this CFM, you need to size this ductwork, okay? So let's start with this. This is very, very easy to size, but let's start with the inlet, okay? The inlet. So my question is in here, actually, hopefully this is not becoming complicated, but see, I'm gonna size the inlet of the VAB, but usually what happens is you contact the representative of Price, Titus, Greenheck, and then you order VABs from them. They will help you out. Hey, you have this system. Okay, the VAB is inlet size already 12 inches. Inlet size is 14 inches or 16 inches, depending on the total CFM. Okay, what's the CFM of this VAB? Let's check. So how much is 285, 1, 2, 3, 4? I'm just going to do that in my calculator. Okay, so what I'm gonna do is actually I'm gonna use this calculator from here. Okay, so what's 285? So we have 285 times 4, right? So 285 times 4, it's nice. It's an easy calculation. So it's gonna be 1140, right? So we're gonna put in here 1140. 11, what is it? 1140 CFM. Okay. So you're going to say to the representative, hey, I have 1140 CFM, and you can always coordinate with them. But just now, so of course, you're going to have in here nominal sizes for the ductwork, but let's just double check on that. Let's practice this, okay? So again, number one, no, again, you have two options. You can use your ductulator, or you can use the online ductulator that I've been talking about, okay? Let's clear units, okay? So I want to size this. You and everyone remember my process. So the process actually was the following. We have 3 questions to ask, and I might be beating around the bushes a lot, but hopefully the redundancy of this is very accurate for everyone, okay? Hopefully everyone is taking advantage of this. Let's be redundant. Question number 1. So in order to size ductwork, we need to know if it's low or medium, okay? So low or medium. Once you get more practice, you're going to do this quicker. Okay, so whatever is entering here, is it low or medium? So we determine this is connected to the main duct that goes to the roof, and you have a terminal unit in here. So this terminal unit is dividing the low pressure duct downstream and medium pressure duct upstream. Okay, so instead of low medium, it's medium. There you go. Number 1. Number 2, is it going to be greater than 6,000, or it's going to be less than 6,000? That's the second question, right? So as you can see in here, what do I need? 1140. Okay, 1140 is actually less than 6,000. There you go. And then number 3 is going to be the criteria. What's the criteria? You either going to size this duct based on friction or based on velocity. Okay, so if it's medium and it's less than 6,000, you have in here, what I'm going to do is I'm going to put it in pink. So see, okay, now we know that it's medium pressure, and then is less than 6,000. Oh, we do friction. What's the friction? Friction rate is 0.2. That's gonna be there we go, 0.2. All right, so there we go. So in this case, let's put in in our online calculator. That's what's the CFM? 1140, and then the friction is gonna be 0.2. So as you can see in here, it says a 12.7. See, I'm gonna put this again. So 1140, and then this is 0.2. See, it says 12.7. So overall, most likely it's not gonna go to 14. So I would say this could be a delta, or I mean, see, this is diameter 12. That would be my inlet. Okay, but this has to go with the manufacturer. It's a very you don't need to do this sizing, you don't need to do this calculation, because these VAB boxes already come in nominal sizes like 8, 10, 12, 14 based on your CFM maximum and your CFM minimum. Contact the rep. They have their own procedures, they have their own team, and then you will get this appropriate number. But this is an example. And now what we're gonna do, and which is more practical for this video, I'm sorry I'm extending the video a little bit more, is gonna be the downstream, okay? So let's continue with that part. So let's go here. Okay. So before, see, upstream is gonna be 12 inches, okay? That's the diameter. And what about this size? Okay, now we're in business. So what is, I'm going to put a star in here. So just to see where we are. Okay, I'm going to put it with orange. So we're right here. There you go. We need to size that part of the ductwork after the VAB. Okay, so what is the CFM in that point, in the start point? That CFM is 1140 CFM. Okay, so now in order to size that, again, we're gonna do my redundancy, we're gonna do the steps. Sizing ductwork is gonna be number 1, 3 steps. Is it low or is it medium ductwork? Okay, now is it low or medium? So after or past the VAB is low, medium, low pressure duct. There you go. So number 2, is it greater than 6,000 or is less than 6,000? It's like a recipe, right? So as you can see in here, the CFM right here is 1140. So it's less than 6,000, okay? So number 3, we're gonna put the criteria. Is it friction or is it velocity? So if we go here to the table, low pressure, I'm gonna put this in pink again. So this is going to be low pressure, okay? So it says less than 6,000 is going to be friction. And then for friction is 0.1. So in here, we're going to put 0.1. You see 0.1. All right. It's going to be 0.1. Or usually what I do instead of 0.1, I put 0.08. It's a little bit more conservative. Okay. So we're choosing friction. Okay, so let's size now the duct. I'm gonna get my ductulator or my online ductulator, and let's put clear. Okay, so what's the size? 1140, and then we size it based on friction. So that's the friction rate, 0.08, and then we're gonna put in here a size that could be good for my height. So imagine that my height, the ductwork height, I want it to be maybe 10. Sometimes the architects are not happy with, big heights. So let's start with a 10. So if it's a 10, 10 by 20, maybe not. Let's try a 12. So if it's a 12, 12 by 16. Yes, more manageable. But a better aspect ratio would be 14 by 14, right? That's the best. However, let's just save space height-wise. Let's put 12 by 16. So technically, this ductwork right here, I'm going to put this in pink just to keep consistent. This part of the ductwork is going to be 16 by 12. 12 is the height and 16 is the width. Okay. Alrighty. So now we're going to go to the other part. So this is 285, and then 285 again. 285 is number one, low pressure. Number two, less than 6,000. So we're doing friction rate again because it's low pressure duct. So we're going to do, instead of 1140, it's 285. So this is going to be 285. 285. And then based on friction rate, which is 0.08, the size of that ductwork, usually for the branches, we use round duct. So we're going to put in here a round duct of what? The round duct, it says 9 right here, 9, right? Let's put it again in here again. So this is going to be 285 and then 0.08. And then see, instead of 9, we could put a 9. Let's put a 10. So we're going to put size work 10. All right. There we go. So technically, so this is going to be 10. And since this is typical of 4, this is going to be ductwork 10. And this is going to be ductwork round 10 duct. And then round 10. All right. Okay. So we're going to go for the last part of the video. So we're going to size the return. So this is the supply. All right. So this is the supply air, but we're going to size also the return. Okay, it's return air. So I'm putting 2 return grills, as you can see in here. So technically, I'm returning this 1140 back to the unit. So 1140 divided by 2, I'm going to put in here, let's see, 1140 divided by 2, that's going to be 570. So technically, this is going to be 570. I'm going to put this as yellow. Let's go here and then change this as yellow. Okay, so this is going to be 570. And you can put in here typical of 2, right? Typical of 2 means these two are the same, 570. So what is the size of this ductwork? So my question is, do you see any terminal unit between this air device that goes directly to the unit? You don't see any terminal device. Therefore, I'm going to classify this as mostly as a low pressure duct. So we're going to put in here low pressure duct. Okay, based on that, we're gonna do again the my calculation. See, if number 1 it's low, number 2 is less than 6,000 CFM, so therefore we're going to go for a friction rate of 0.08. all right, so let's go bring the ductulator in here. It says gonna be, I'm gonna clear units, and then this is 570, and then head loss, let's see, friction rate, that's 0.08. all right, so my diameter, because it's just one duct, okay, my diameter is 11.8. technically it's a 12. I'm gonna have a 12 round duct. There we go. I'm gonna put in here 12, and since this is the same, it's gonna be a 12. Okay, easy peasy and rigid. However, for example, if I want to put this as rectangular duct, I'm going to start with a 10. So see, this is a 10 by 12. Or I'm going to put, yes, a 12 by 10. Okay, so this is equivalent to the 12 width by 10 height. This is equivalent to the 12 width and 10 height. But you might be wondering, wait a minute, Roberto, this is 10 by 12. And why are you putting 12 by 10? Because it doesn't matter. You can even put in here 12 and it's gonna give you 10. Or you can put in here 10 and it's gonna give you 12. It's the same. So that's why I always start with the height in here. So technically this is the width and this is the height. But since this is interchangeably, so we can switch this. That's why I consider this as a height. Okay, let's do a height of 10. So the width is 12. Okay, so hopefully everyone is understanding me. You can switch it, okay? So that's why this is the equivalent. And then for this big ductwork, I would have to size it as as a low pressure duct, but this one is as a medium pressure duct because it's connected to the terminal unit. All right, so I hope you enjoyed this video, and don't forget to leave a comment. Any question is always very welcome. Thank you for watching HVAC Christmas channel. In the next video, by the way, I'm going to be showing another example on sizing ductwork. Okay, thanks so much.